Hello and welcome to another episode of the DroidDevCast, a podcast by the team here at Esper, bringing you all the latest thoughts and news on all things Android, DevOps, and open source software development. I'm your host, Rin Oliver, and today I'm joined by Keith Szot, VP of Technical Sales, and today we're going to talk a little bit about Esper's new device lab. We recently got one set up at our office in Bellevue, and it's amazing. So I thought we'd sit down with Keith and talk a little bit more about the philosophy of the device lab. That actually leads me right into my first question. What was that philosophy driving the design of the device lab?
Ren, first of all, super stoked to be here. I love to talk about the device lab. I'm an electrical engineer by training, did ham radio when I was a kid. I love this stuff. Where software and hardware meet is where I like to sit. And so the interesting thing about this Android world is, I like to say that each device is like a snowflake. When you look at the unique combination of the hardware design with the firmware that's on the device, literally no two are alike. Even when you get into like the same manufacturer across different models, there are a lot of unique aspects of it. And, that shows the power of Android because unlike, Apple with iOS, where basically you have uniformity across iOS as a whole, and there's not a lot of variation necessarily between models in Apple's lineup. In the Android world, it's very complicated. And so you have some that are part of GMS, which is provided by Google, which is enforcing some uniformity. But even there, it's a little bit jagged, especially across all the Android OS versions. We support from 4.4 up to Android 11. And then when you get into AOSP, so basically open source Android-based devices, it's anything goes. And so we've seen a lot of good things and a lot of crazy things in that world. So, that variation drives our philosophy around the device lab. In order to be effective at building our platform and supporting customers with their huge fleet solutions, we really have to have a diversity of devices to be able to work with as we develop our platform and make sure that, in a sense, the end targets, the devices themselves, are properly supported and covered, and it is very diverse. So it really is a challenge, which frankly is why I think a lot of companies in the space, our competitors, if you will, don't like this area because it is very complicated. It's not cookie cutter, and frankly, it takes a lot of work to be successful in this space. And by the way, I think our customers appreciate that.
Absolutely. And speaking of our customers, how does having something like a device lab help our customers?
Yeah. Well, that's where we need to deliver, right? Because otherwise, why are we doing this? And really, it's about kind of keeping pace with the customer. Think about it from a repro situation. If a customer has a problem on their particular device, sometimes the only way to reproduce it is to literally have their device in the lab. Now, we have some features that are great for remote diagnostics and remote debugging. Like we enable you to do a secure remote ADB session to a device in the field from your developer workstation. That stuff is great, but it's not 100%, especially when it's Esper, because Esper is the device owner, and we basically take a unique level of control of the device, if you will, for the benefit of our customers. And that puts us in kind of unique situations where you literally have to have that device available with that same firmware image that the customer is working with in order to reproduce the problem. And essentially, this goes back to, faster turn time on resolution. And in some cases, just the ability to identify the problem and to be able to fix it. And that comes down to having the device in the lab. So basically with our larger customers, and of course, we can't do this for everybody. And so we kind of have an approach of how we break it up. But for the large customers, we have their hardware in our lab. So that way we could be apples to apples. Again, I live in Washington State, so we have a lot of apples with what they're running. Now, when you step back from that, we also have a lot of smaller customers that use Esper. And those customers typically are using like the major OEM devices that are out there, Lenovo, Samsung. And so we also do our best job to have representative devices that kind of map to what the broader set of customers use. So that way we can get coverage. So you put those two together, and then we have the set of devices that we need to be effective at reproducing. And just to give you one more example, we do work with a lot of custom built devices. So some of our customers literally are designing the hardware from the ground up with a specific AOSP image that sometimes we help them build. And we also have Esper Enhanced Android that we offer too for these custom built devices. And in that case, you literally have to have the device because it doesn't exist anywhere else in the world from a lab perspective. And so, we basically have to pull it in and have it available.
Wonderful. That sounds great. That makes a lot of sense. So, in that vein, how does Esper use the device lab internally? What are we doing to use that on our end?
Yeah. So that relates to the previous point of reproducing bugs. But, more fundamentally, we also use it to the benefit of testing our platform, right? And so it goes two ways because as we advance a platform, introduce new features and capabilities, we're very dependent on not only what our cloud does to talk to the device, but also how our on-device code runs. And so in order to have good QA as we go through the process, we need to have these devices available for our dev team to be able to test and do QA on. So that's a super important aspect of it. And then two, really for a rapidly growing company with a lot of new people coming in, the device lab is invaluable to really get up to speed on the diversity of the devices, be able to play with them across all the different Android OS releases, and really get a feel so that way we can help prospects and customers make good decisions about how they're designing their solution and even be in a position to help them make decisions about what type of hardware they should buy. That's a common scenario where, from the customer perspective, we have a lot of people moving over from Windows over to the Android world. They're fairly new to Android. They don't understand kind of how to evaluate, given their target solution, what kind of device that they should select and what are the trade-offs involved with that decision. And so this spans both kind of your consumer devices and how you adapt them for these dedicated device use cases, as well as over to the custom design. I mean, we have development boards from Rockchip, Qualcomm, of course, MediaTek, who's a partner of ours, and really just kind of at that level, just understand how do these boards perform, right? How do they behave? What peripherals do they have built in? What are, potentially their thermal characteristics, their power consumption characteristics, all these nitty-gritty details that are really, really important when you're building these custom devices that I think a lot of other companies just don't deal with because that's not their focus. That is our focus.
That makes a lot of sense because that way in a lab you can see, does this device run hot? Does its battery drain too fast? What is it doing under extreme load, etc.? So in that vein, what are some of the most interesting devices that Esper has in the lab? Are there any really cool ones? I want to know.
You do. Yes. Part of it is kind of what I call meat and potatoes, right? And, the consumer devices are adapted a lot for these dedicated device use cases. And I got to say, I'm really impressed by the tablets that Lenovo is coming out with. Their M8 and M10 line, they're very well built. They're economically priced, great performance. They're just a set of trade-offs, right? So I've been in the OEM world before, and I know it's really tough when you're doing this kind of device design and you're thinking about like your bill of materials costs, right? How are you going to support it? Your industrial and mechanical design, tons of trade-offs, lots of people involved, and they're doing a really, really good job there. Kind of like in the next round, you think about these like vertical market devices, and these are typically for specialized use cases. And so, you got to mention Zebra, right? The Zebra TC20 and that whole line is just an amazing, compact, very effective, rugged device with lots of different options for barcode scanning and just a very well-built device. Now, kind of at the other extreme, you get into like very, very specialized OEM devices. And that's where Sciata comes in. And so Sciata has the UV350 that's designed for public safety. It works on the FirstNet network in the United States, which is part of AT&T. And that device just brings me back to my ham radio days. To me, it just looks like a rugged ham radio that's built for communication, but has modern data built in. And then we next go to kind of the custom built devices. Now, this is a little tricky because with this, we're literally working with customers that are preparing devices for market. So I can't say too much about that necessarily, but in the fitness space, we're getting some very interesting devices that are being developed. And so essentially, how do you integrate screens into equipment, understanding that those screens are also the CPU processing power to control the peripherals, if you will. And these things are integrated into the device itself. So it's things like if you do the consumer case, like making the exercise harder for the user because they're doing like a virtual class or something like that. And this also applies into the medical space around rehab and things like that. In fact, one of our customers is ROM3 Rehab. They're doing some great work in terms of how they're applying kind of the quasi custom built device into their solution. And I would be negligent if I didn't mention our Big Pause device. Super cool kiosk, very economically priced. It actually runs Esper Enhanced Android. And so that's kind of the sidebar, is to say, not only are we doing all this device stuff, and not only do we work in AOSP, but we have our own Android build that's just designed for this dedicated device use case. It was one of our first prototypes to do it. And so we have this kiosk that you just basically boot it up first time. It enrolls, provisions, how you set it up. And it's a very sleek, nice looking kiosk. And so it's kind of like, which is your favorite child, right? It's can't really say, but you kind of got to go through the attributes of each one to really appreciate the trade-offs involved in them. And it's the same thing with the hardware in the lab. I could go on. I think I've said enough, but maybe another time we can dive into more of that.
Perfect. That's actually leading me really nicely into my next question. That sounds great. Yeah. Choosing my favorite device would definitely be like choosing my favorite child, I'm sure. I'm a sucker for tablets. I love them. So does Esper buy the devices or do we get them on loan? How does that work?
It really is a combination. One of the things that we did as we built out our device lab is, and this is at the prospect phase typically because they're not customers yet. And so we kind of have a net new walk-in for a prospect that has a particular device. And if it's a generally available device, we'll go out and buy it. Occasionally, the prospect will send it to us as a loaner, so we do that. But it kind of goes back to, we're building out and maintaining our lab. And so that means that we have to have consistency, right? And so a loaner is just that. It's there for a period of time. We have to send it back and then it's gone. So we've decided to make the investment in purchasing the devices so that way we have a stable lab. Once you get into custom built, it is a little different because those custom builds are typically loaned by the customer. And so, they move from prospect to customer, if you will. And so it goes to, during the prospect phase, perhaps they'll loan it to us, we'll check it out, validate it, and then help them through it and then send it back. And a lot of times they just say, hey, keep it, because it goes back to that repro case and we have it there and it's available. Now, there's kind of a nuance here that a lot of times these custom builds are based off of reference designs, if you will. So like we work with Intercom, and Intercom has their SB30 board. It's a system on module. It is designed as like a development kit. And think of it as like the base starting point for a lot of custom designs where, you'll prototype on that board, you'll get the Gerber files, which basically describe the layout of the printed circuit board, and then it'll go to a design house and they'll relay it out based on the form factor that the customer wants to do, pull out pieces that they don't need, stuff in new pieces they do need. So kind of like an example would be, I don't need Ethernet, but I need to drop a GPS chip into that, right? Basically stuff like that. So the point being is once you get to custom, okay, but we also buy and own those base reference designs so we can be right there from the start. And so the SB30 EVK is an example of that.
Great. And does Esper use the lab for device qualification?
Great question. Yeah, absolutely. So what we do is when we inbound a new device, we have a process that we go through that one part of it is just kind of a general evaluation of the device compared to what we think the targeted use case is. So this is stuff like, usability, durability, how is the ID and the ME, industrial design and mechanical design? How does it, like basic things? How easy is it to like charge it if it's a battery powered device? Access some of the connectors on it. And that's interesting itself because actually for some use cases, you want like power button and the connector to be really hard to get to, right? Think of a cash register or a point of sale terminal, something like that. In other use cases, you want them to be easily accessible. So like the opposite end is, let's say you have a tablet in a space that a user will interact with it periodically, right? So think about like a warehouse or something like that where they need to dock the devices at the end of the day. How good is that dock? Because if it doesn't dock properly and charge, it's lost for the next business cycle. So that's kind of one general aspect of it. Another one has to do with kind of the performance of the device. So again, for the use case, you have to, first of all, benchmark it. What's the battery life like? How does the screen work relative to video? How effective is the touch screen? So stuff like that. And we typically run basically benchmarking tools on it to collect that data. And then the final part is to look at it for how does it work with Esper? So this is things like how does enrollment and provisioning work? There are multiple methods to be used. Each one is different because the kind of the flow for enrollment is dependent on the specific setup implementation that the device maker has decided to put in it. So they can be different. It's things like what were the decisions made with the firmware build. We run into situations with ODM devices, and so these are original device makers, and they tend to be suppliers to a lot of our custom built customers. We've seen situations where, we're device owner, they flick on device owner and set it, and they basically block anyone else from being able to do it. And so that means it's useless to be able to be controlled. So that's one general example area. And then it goes to things like exercising with Esper. Does app install work properly? Do controlling settings work properly? There's weird anomalies you see. Like a good example is screen orientation. Sometimes the device maker implements it in a flipped manner, meaning the portrait is landscape and landscape is portrait. Just stuff like that. And it's literally in their Android framework what they decide to do. Another one is, with Android, Google sets up, in some cases, a set of flags that the MDM sets that the OS is supposed to respect. And that's system update on these GMS devices. And it's good to know because guess what? Not every device maker respects those. They're there, they're supposed to read them, but they don't necessarily do it 100%. So as you can see, there's a lot of granularity in here, and that's the level we like to dive into, which goes back to why our prospects and customers entrust in us our advice when they make these decisions to standardize on a device. It's a difference between hardware and software, right? The software mentality is, I got a bug, I can push out a fix. But when you put the money on the table to buy 10,000 tablets, it's not cheap. And you're going to be stuck with that for a long time. So it's a much, much bigger decision from a capital expenditure perspective that needs to be carefully considered by our customers. We totally appreciate that. And we're super happy to help them through that so that they can make the best decision possible.
Absolutely. That makes perfect sense. And so for my next question, I was wondering how the lab works between the team in India and the team in the US. We are a distributed team, so I'd love to hear how we, in essence, share the lab and communication from the lab gets back and forth between our teams.
So it is a two-way street. APAC in general has some unique device makers, OEMs, that we don't see in the US. So think of Redmi as an example. You do not see a Redmi device in the US, but they're very common in India. And then, the converse is in the US, you see Ciata, but currently you don't see that in India and in APAC. And then, of course, you have OEMs that span both markets, like Zebra, Samsung, Lenovo. They're in both, but there tend to be models that are more popular in one region versus the other. So, when you kind of look at it, part of it is our dev team needs to have access to test devices that are representative of the world. And if that device is not available in their region, it makes it very tough for them to do so. Thus, having them available in the other lab, which in this case would be like the US, so that way they can test against the Ciata device and be able to validate it as part of our QA process, is super, super valuable to us. And then conversely, there are times where in each market we find a customer that has kind of a unique device that is not in our lab but is in the other. So it's super useful for those repro cases as well. And it kind of points to, hey, we have a worldwide perspective on this. What we're trying to do is have a worldwide view of the popular devices, the appropriate devices that are used by these customers for these corporate-owned single-use solutions that are based on Android. And I think the combination of being able to procure, source, and loan out of the US for basically the Americas and Europe, combined with our ability to do that for APAC, just gives us incredible coverage over all sorts of different device types.
That makes a lot of sense. That's actually really cool. Living in New Zealand, I did see a lot of different devices that just were not in America, and I'd never seen that phone before, but it was there in New Zealand, and everybody had one. And I was just like, huh. They were mostly Androids, which was interesting. The iPhones, there were no really differences, but there were so many more Android models and devices and manufacturers that I hadn't seen in America when I was in New Zealand, so that was pretty neat.
And you know what is going to happen now? The next time you go back, we're going to give you a suitcase and a budget, and you're going to buy a bunch and bring them back. So sorry about that.
That sounds fun. Yeah, that sounds great. I'll do it. It'll be fun. And speaking of fun, what's the funniest story that's come from the device lab? Do you get up to any hijinks? Is there anything funny going on over there?
Well, this is actually kind of a bundled story where, when COVID hit, we were in a tough situation with our lab. It's physical, it's there. And in our state of Washington, we were barred at a certain date of being able to be in the office. And so what I had to do is basically disassemble the lab, transport it to my house, set it up at my house, and maintain it there during our lockdown period. We're in a different phase now, so we have the ability to access the office within guidelines and all that kind of stuff. But back then, it was a tough choice. So guess what? I had to bring all this stuff back. First of all, I discovered that through my internet provider, there's a limit to the number of devices that can be connected through the Wi-Fi access point they supply, right? And my family let me know when my daughter was not able to play Animal Crossing anymore because I cut her off. So found that out quick. But the best one is somebody, and I won't say who it is, decided to play a nice joke on me. We have a geofence feature. And so basically you can define a geofence, and if the device is outside of the geofence, you can make it beep or lock it. So this joker basically purposely set it up so that every single device in the lab at home was outside of the geofence. And all of a sudden, in the evening, it wasn't late at night, thankfully, every device in the lab that was now in my house started beeping. My family just was like, what the heck is going on?
Oh, that's fun.
It took me a little bit to figure out, right? Because it's just like, what? And then it's like, okay. All right, who's the joker? Someday I'll reveal who it is, but it was a pretty classic moment in the device lab. Home edition.
That is hilarious. I love everything about it. Well, I'm looking forward to getting up to some hijinks when I'm on site in the device lab next week for sure. That'll be fun.
Looking forward to seeing you, Ren. As always, a pleasure, and I hope everyone enjoyed this journey through our device lab.
Absolutely. Thank you, everyone, for joining us. That's it for another episode of the DroidDevCast. You can listen to us on Spotify, Simplecast, SoundCloud, or wherever you get your podcasts from. You can follow us on Twitter at EsperDev. And please remember to like and subscribe to our YouTube. And we'll be back next week for another exciting show.